In this lesson, I'm going to show you how to calculate horizontal and vertical components of a force. Forces are not always applied horizontally or vertically on objects. Sometimes forces are exerted on objects at an angle relative to a surface or the horizontal, as in this man here. Because the rope runs over his shoulder, the rope makes an angle of 25 degrees relative to the horizontal. Now let's take an example. Here's a 250 Newton force here. The force is applied at this point, 30 degrees above the horizontal. Now the force can be shown on a Cartesian plane. The force is drawn in the first quadrant. The force is drawn 30 degrees above the positive x-axis. Now think of this force as being the resultant of two other forces, the blue one and the green one here. The blue one, Fx, is the horizontal component of the force, and the green one is the vertical component of the force. Now, the horizontal component of the force pulls the object along the surface, while the vertical component tends to lift the object up or in the vertical direction. Now, the next question is, how can we calculate the size or magnitude of these two forces? Now, because this is a right-angled triangle, we're going to apply trigonometry. And we see that Fx here is adjacent to the angle 30 degrees, while the 250 Newton is the hypotenuse of the triangle. Therefore, we can write Fx over 250 Newtons is equals to cos 30 degrees. Therefore, if we make Fx the subject of the formula, we're going to get 250 times cos 30 degrees. The answer is 215,51 newtons. Now our next step is to calculate the size of Fy. Because Fy is opposite at 30 degrees, we're going to say Fy divided by 250 is equals to sine 30 degrees. Making Fy the subject, we get Fy equals to 250 sine 30 degrees. This is equals to 125 newtons. Now we know the magnitude of Fx. This is 215,51 newtons, and this is 125 newtons. Now note that if the given angle theta is between the horizontal and the force, Fx is going to be F cos theta, and Fy is going to be F sin theta. This is not going to apply if the given angle is between the vertical and the force, like this one here. So if, let me repeat, if the angle given is between the vertical and the force, then we cannot apply these two formulae here. But for as long as angle theta is between the horizontal and the force, therefore Fx is going to be F cos theta and Fy is going to be F sin theta. So next time I do this problem, I'm just going to find the angle that is between the horizontal and the force if the given angle is between the vertical and the force. More problems. 12,5 Newton force pulls a block to the left at 30 degrees above the horizontal as shown. Calculate the vertical and horizontal components of this force. Now, I need to draw a Cartesian plane and indicate the force. Here's my 12,5 Newton force. The given angle is this one here, 30 degrees. Now, the force is in the second quadrant. In the second quadrant, y is positive. Therefore, the vertical component of this force is going to go up. It's going to be pointing up, sorry. and the horizontal component is going to be pointing to the left. Okay, so this is going to be Fy, the direction of Fy, and this is going to be the direction of the horizontal component, Fx. Again, I note that the the angle that is given is just between the horizontal and the force itself. Therefore, Fx is equal to F cos theta. This is going to be 12,5 Newton times cos 30. This is equals to 10,83 Newtons to the left, okay? Because the force is in the second quadrant. And the magnitude of Fy is going to be F sine theta. This is going to be 12,5 Newtons times sine 30. And the answer is 6,25 Newtons. This is up in the positive y-axis. Here's another example. A force of 12,5 Newton acts at an angle of 230 degrees to the positive x-axis. Resolve this force into components. Here's a diagram given here. At the 230 degree angle is not an acute angle, really not between the horizontal and the force itself. Therefore, before I can substitute into the equations I gave you, I need to find the size of this angle here. Now, this is 180 degrees, okay, plus this angle here. Let's call it theta. Now, 230 degrees is equal to 180 plus theta. Therefore, the size of theta is 230 minus 180 degrees, giving us 50 degrees. So this is 50. So the angle between the horizontal and the force is 50 degrees. Now I can go ahead and calculate the size of Fx. It's going to be F cos theta equals to 12,5 Newtons cos 50 degrees. And the value of Fy is going to be F sine theta equals to 12,5 sine 50 degrees. Now I need to calculate the size of these two forces. Now this works out to be 8,03 Newtons, and this one is 9,58 Newtons. What about the direction? What is the direction of these two forces here? Now the force is in the third quadrant. Now in the third quadrant, this is negative x-axis and this is negative y-axis. Now in the x direction, the force is going to be pointing left. So therefore, this is left. In the y direction, the vertical component is going to be pointing down. So this is down. We need to write down here. Okay. Here's another example. A boy pushes a toy car to the right by applying a force of 80 Newton at an angle of 40 degrees above the horizontal, as shown. Resolve this force into components and include direction in your answer. Here, the Cartesian plane is not given, so we draw a small Cartesian plane. In which direction is this force, this one here, acting? The force is acting in the fourth quadrant, so we include the force in the fourth quadrant. This is 80 Newton force. What is the angle in which this force is acting? The force is acting 40 degrees below the horizontal. How do I know that? The force was here and the angle here is 40 degrees. Now if this angle is 40 degrees, also the angle opposite is 40 degrees. Hope you know that from math. Alright, our next step is going to be to calculate the horizontal and vertical components. but I can also include them here on the Cartesian plane. This is the horizontal component. The horizontal component is to the right because in the fourth quadrant, x is positive. So therefore, the horizontal component is going to be pointing in the positive x direction. The y component of this force is going to be pointing downwards because this is the fourth quadrant, and in the fourth quadrant y is negative. All right, this is Fy and this is Fx. Next, we calculate the size of Fx and Fy. Fx is equal to F cos theta. This is equal to 80 cos 40 degrees. And this is equal to 61,28 newtons. The direction is right. Fy is equal to F sine theta. This is equal to 80 times sine of 40 degrees. Now this is 51,42 newtons down. Now guys, if you like the content of this video, please subscribe, okay, and help me reach out to more people. Thank you. See you next time.